Dear learners, I hope you have gone through my first two lectures. This is my third lecture as part of Managing Industry 4.0. Today agenda of this lecture is that we will quickly learn what we have done in the first two lectures. Then today we like to discuss the foundational technologies of Industry 4.0, and one of the important technologies is IoT. So, the focus of today's lecture will be on connectivity and IoT, and other areas, other technologies we will be discussing subsequently. Then we will go a little deep down of the IoT, why IoT is required, and what is the architecture or internal of IoT. And then we will also go little bit more how IoT is facilitating industry and giving them a new kind of dimension of using technology for their growth and connectivity. And we will end this lecture today with few examples of IoT and a live case study of TVS Motor. So, this is today's agenda. Now, if you recollect, in the first lecture we have learned what is Industry 4.0. Industry 4.0 refers to the smart and connected production systems that are designed to sense and predict and interact with the physical world, so as to make decisions and that support production in real time. And if we consider today in manufacturing, it helps to increase the productivity, energy efficiency and sustainability, and many other advantage Industry 4.0 is delivering to the manufacturing. And it is characterized by the integration of advanced technologies such as artificial intelligence, big data analytics, Internet of Things, robotics. And on the right hand side picture, some of these technologies has been shown. So, today we are picking to discuss in depth what is IoT, how it is deep rooted in Industry 4.0 implementations. In the second lecture, we discussed this schematic diagram of using foundational technologies in a manufacturing value chain, and you will find here that there are four areas. But I will not say this is only four areas, there are many other areas. One is the connectivity, data and computational power, which comprise of sensors, Internet of Things, that is IoT, cloud technologies, storage technologies, etc. Then we have analytics and intelligence, which is the big data analytics, advanced analytics, machine learning, AI, what not. So many technologies are there, which we will be learning subsequently, as I said earlier. And then advanced technologies like human machine interaction, virtual VR, AR and VR and robotics, automation technologies, and then finally additive manufacturing, 3D, renewable energy, nanoparticles, which add to the advanced engineering. But today's lecture focus is on sensors and internet technologies, which we like to view. So, it is something which is connected to the, I will not say framework, but in case somebody wants to, you want to implement or you want to learn, the IoT become one of the fundamental technology. I thought before we go had discussing some other concept of Industry 4.0 like framework and processes, drivers and some other, let us first establish a good foundation of learning of Industry 4.0 by discussing these building technologies. These are the building technologies for Industry 4.0. But they are not all, as I said, there are many others which we also will be learning. Now, let us first try to understand the connectivity aspect. And you all are students, you on a daily basis you work on the LAN area, local area network in your office or in your colleges or universities, and you work in your house on a wide area network. Your computer is connected through other your ISPs, and then you are able to work on your computer in the wide area network. But this picture is more or less for the corporates or enterprise. This is a typical requirement in the corporates. Internal connectivity is through LAN, and then corporate offices are connected to the outside world through a wide area network. Suppose companies having more than 1 or 2 offices, then wide area network become the next city. So this is a simple diagram. I thought before we go on the IoT, we show that this is the conventional way of connectivity. And here no devices like your turbine or your device like your doorbell, which we will be discussing, or your car, they are not connected. There is no facility to connect like this. Then it is better to discuss about the IP, that is the Internet Protocol. I thought to have a complete discussion, it's better to understand what is IP, what is Internet Protocol. So definition of Internet is a rule. It is a primary set of rules that govern how data is sent and received over a network or the Internet. So one should understand Internet Protocol as a primary rule. Like I am speaking in English, and you are also understanding my English. There is a translation going on, there is a communication going on, between myself and you. There is something called the protocol, English protocol. So like that, when you connect multiple computers and they all follow this language of Internet Protocol, the language of connectivity Internet Protocol, they understand what kind of data is coming, what kind of information is coming. So this is become one of the leading connectivity protocol. Then what is IP address? IP address, as we know, when any parcel comes to my house, my house is having a unique address. My house is recognized by a unique address. Like that, every computer, every device which is connected on the internet or on the network, is having a unique address. So it's called IP address. This itself is a subject. IP address, I am not going in detail of that subject, but one should know that IP, Internet Protocol, will not work without understanding the IP address. What is function? It is responsible for addressing and routing data. So once the address is known, then it helps to route the data to the right destination, right computer, right place, so that address become one of the key aspect in the whole schema of Internet Protocol. Internet Protocol is having 5 layers. The bottom layer is physical layer where your computer is connected, data link layer, network layer and transport layer. I am not going in detail of each of these layer. Transport layer is very important, through which your computer is there is a logic residing in the network device which is connected to your computer, and that logic is having a part called transportation. With the help of transportation, after knowing the address through network IP, then data is being transmitted on the network. We will be learning those networks. They may be Ethernet network or they may be wide area network. So the transport layer helps to transport data and your information on the network. And application network basically is to understand what this data is meant for. Is it a cyber attack data or it is a something banking data? The application is a very important aspect. So and here protocol is having that capability to transmit data, even it is receiving in some other format in the right format. So that is the function of the application. This diagram shows some of the connectivity pictures. There is a direct connectivity of computers to the local area network, which we do in our offices, and then there is a internet connectivity. So the first picture is a direct connectivity, where there is no IP protocol is involved. IP protocol is not involved in the first case, which we find normally in some of the factories. IoT devices are not being used. And in the second case, you will find that multiple computers are connected on local area network through IP. And then the wireless connectivity, we all know about that. My phone is connected on the wireless. So this is the wireless connectivity is another option which through which we can connect to the local area network as well as wide area network also, which is not being shown in this picture. And then we are having multiple options of cellular connectivity. Cellular connectivity means you are on the move, but you are connected to the network. And that is what the beauty of this network, the way it works. But the basic, the principles of the network, what we discussed in the previous slide, is same. It will not change. It will not change. That whenever the connectivity is established, it will go through these 5 layers translations. It will go through these 5 layers. Then only network will recognize this data is coming from which computer, from which address. So I hope you would have understood. You must have developed a very basic knowledge about this network. And I will invite you that you should study network protocols about the network. In this session, I am not discussing about too much about the network, but it is imperative. When you want to work in Industry 4.0, network and connectivity are one of the fundamental technologies, and which is not only in case of Industry 4.0, it applies generally everywhere. So without network and connectivity, we cannot work in this digital world or IT world. Okay. So now, before moving to the IP, if you see on the left hand side, before IoT was discovered or IoT started taking the industry applications, earlier the devices like pump in the factory or some other devices like furnaces, turbines, if we like to connect these devices to the computer, then they were having a direct connectivity. The computers, normally we call them SCADA systems. SCADA system in the factory or in the manufacturing plants are the systems which control the working of all equipments in the factory. So this is a SCADA system. A SCADA system may be used for the different purposes are there for SCADA system. I am not going detail of that, but some companies are having SCADA system, some company may be having some other kind of system. So connectivity here is through direct. So it has since SCADA system is not connected to any IP network, so it has limited facilities to use the advanced technologies like HMI. In case of we want to see the graphs, we want to see the dashboard, we want to see the plant, inside, through the simulations or this kind of technologies are not able to connect. So this is something we will say that when IoT was not there, this was the situation earlier. Now with the help of IoT, we can connect all these devices to the internet network. And we can take advantage of facilities available on the internet network, in my company network or maybe global network. Let us see on that. Now I come to the official definition of IoT. As this pictures, right hand side pictures shows that with the help of IoT, you can connect anything. Earlier we were able to connect only computers, or laptops, or mainframe computers, or mini computers. But now with the help of IoT, we can connect everything, anywhere, to any other computer which is also following, or any device which is also following IoT, anytime, 24/7, and any place, any service, any network. So this is a very good diagram. I thought we should show this diagram to you anytime, anything, anyone, anytime, and any place. And this picture speaks the viability, the scalability of IoT. If you see that here, real physical world, we are living in the world where trillions and trillions devices are there. How we communicate Before IoT start taking place in the industry, we were able to connect only computers, only computers, But now today, any device which you feel has to be has to be used, data has to be used from the device, which we will see very soon in this lecture itself, can be connected with the help of IoT. We can integrate the data which is coming from the device to which IoT is connected, or which IoT enabled device. We can capture the data like temperature, pressure, whatever data we want with the help of IoT in a central server or the cloud, and then when we can use the data for some other purposes. So IoT has become the de facto I will say, a communication through which we can capture the data from any device. IRC, this is a Internet of Things research institution in Europe, and says that the Internet of Things is a network of physical objects that contain embedded technologies to communicate, sense, or interact with their internal states or the existing environment, and the confluence of efficient wireless protocol, improved sensors, cheaper processors. I will like to explain this definition with the help of subsequent slides, rather than explaining right now. We'll go one by one all these principles which make the Internet of Things as a viable network of physical objects. In this slide, I have explained all these 5 functions and options of Internet of Things. The device, as I said, this can be any device. It can be any device. It's not necessary that you should have a computer, but any device can, as long as device is generating some data, some kind of data like temperature, pressure, whatever. I have an internet device at my door, and it generates the picture, and as long as somebody comes, I get a alert on my phone. Somebody has come and he wants to come to our house. So like that, anything can be a device. Sensor, it is a very important component of IoT. Sensor, it sense, it sense, like I am using IoT for fire detection. So sensor, there should be a sensor attached to the IoT device which sense the fire, and that fire data is being captured through IoT, and then it is being processed, or then the further action can be taken. Similarly, actuator is also a complement of sensors. Once suppose we are connected, we'll see in subsequent examples, we have connected a turbine, and turbine is giving some problem. Now actuator will get that problem, sensor will get this data, it will send to the network, through the network to the central processors unit where the analysis is being done, and then once the decision has been taken by the analytic platform, then it will transmit that data. This will transmit to the alert to a engineer who will apply some tools and technology, that's why you call actuator. So sensor and actuator work together. Connectivity we have already discussed, and in case of IoT ecosystem, data processing is not part of IoT device. It is residing outside IoT. But IoT will have no meaning unless we have some data processing or is connected to some cloud platform. And then we have a requirement of interfaces, applications, which we will be learning in this lecture. This diagram shows schematically what I have explained just now, that IoT device is having role or capability of sensing and actuations. It sends data to the network. Device connectivity, and then this data, once it's being sent to the network to the central processing unit here, and it will take cognizance of the data, it will process the data, and it will if there is a action required, it will take action. Otherwise, the data will be captured and kept in the database. Database, it can be a data lake, or now the new technologies like data fabrics has come. So that is what is the function of IoT. Now in this picture, I have shown the component of IoT in form of images, in form of a picture. which I have explained earlier, but you can see that here basically there are three key components. One is the physical object interaction. Second is that microcontroller in IoT device is an electronic device, is an embedded device. Whenever we call a device as an embedded device, it has both things, hardware and software. Hardware and software, and if the software is programmed on the IC, on the circuit, so there is chip which is programmed for the which is programmable chip, and the program run on the chip. So that you should not you should have this general knowledge, or you should have some basic knowledge about the embedded devices. So this is an embedded device which we will see that soon how it is being attached. It has basically these three components, and then it has sensor on the top of that which sense the data which you want to capture, and then it has capability through a smart hub to transmit this data to the cloud platform and data processing unit. So this is a three-layer architecture of any IoT device, but now there are advanced IoT devices which I am not right now discussing over here, but this is a basic three component of, or three layers of the IoT device. Now let us take example to understand IoT a little better or little deep. Here you are seeing the picture of some turbines, and turbines are connected through the IoT to the network and turbine is sending periodically some data which is being analyzed by its data server. Data server is running some analytics software which analyze the data malfunctioning of these turbines. Data is received, data server is having capability to analyze the data. Once they find any anomaly, it is being transmitted. That alert is being sent to the technician, and technician take control remotely and try to fix that problem as far as possible. So this is a very basic loop of how the IoT is facilitating a remote action through remote location. Technician can solve a large number of problems, but some of the problems may not be solved which require the physical attendance of this unit. If I like to interpret what I have explained, these three steps, so physical layer and perception layer, what we have learned previous to that slide, it has original asset is a turbine, physical object, being monitored for the health and performance. This is the one component, and then sensor directly attached to the turbine. They measure the physical state of the turbine, and connectivity protocol of the sensors are little different, And then microcomputer embedded modules, the brain of the IoT, it collects data from the sensors, process, and then convert analog to digital filters and prepare for transmission. So this is a basic knowledge about the IoT. This is a basic knowledge about the IoT which is applied in this case. Then network transport layer which we have seen on the picture on the right hand side. You can see the picture on the right hand side. This is the network layer, what it does. There is a gateway here, aggregate data from one or more nearby turbine devices, perform local processing unit, edge computing I will be discussing later on, not in this lecture. And then, so this is, if you go through these three slides which I have included in this deck, you will easily know that how this IoT device is working, how it is helping to capture the data from the turbines, and how the data which is being captured from the turbines are being processed. Once some anomalies are being found, then how the actions is being initiated. So this is a full loop which I have tried to show with the help of these three slides. An application layer also which is being explained over here. And this picture give a very good view of the entire this data flow, turbine to sensors and sensors to microcontrollers, then IoT gateway, cloud ingestions, analytic platform, alerting, and user interface. User interface is basically used for taking action by the technicians. So without that, it will remain only in the alert state. Like you had a notification, but you don't take action on notification, and that is to be taken through a user interface. Another very important concept of which I like to share with you is that how IoT devices, what are the connectivity options for the IoT to connectivity options or network connectivity options of IoT, especially in the wide area situation when you are outside the factory environment. So, we call it cellular IoT. Cellular IoT connect the IoT devices using mobile networks, which has been given here. There are three kinds of mobile networks, LTE, narrowband IoT, and 4G and 5G, which we are in our phones we are using 4G mostly, and now 5G is coming also shortly. So, IoT can be with the help of this connectivity or this kind of networks. IoT has become global now. Globally, any device sitting in India, you can monitor any device in US or even other countries, and this is what being done, and this is possible only with the help of cellular networks, because connectivity of IoT is not only in case of local area networks. In this slide, I am showing that kind of devices which can be which are being normally connected with the LTE kind of protocols or LTE kind of network, or which is connected with the narrow band IoT like smart meters, environmental sensors, street lights, and which are connected the high speed networks, which require very high speed transmissions like driverless car, or robots, or drones. Like drones, transmission is also very high speed transmission where we need 4G and 5G kind of network transmission protocols. In this slide, I am not going to go through this slide, but I have included some of the notes which you like to go through and understand better about these network technologies. And please go through this. So the situation how we have now migrated from earlier backbone. We were having backbone kind of connectivity. Now we are having a cloud connectivity. Now Internet of Things has become now a globally available. You can connect any device globally and monitor or access the device sitting in your country. So this is something which one has to understand that with the help of IoT now we are able to access. This is some very good slide which I thought let us show, and this is the actual what is happening today, that the whole world is connected. Whether you are in a smart building, smart factory, smart grid, smart mobility, everything is connected now with the help of but in a secured manner. You can't access everything, unless you have the right, unless you have the authority to access those things. Here in this slide, I have explained the sensors layers in IoT. I will like to keep this for the later explanation because this is very important subject to know how the sensors are working in IoT. So we may have to have a short session on IoT later on. But I want to end this with some example which I have mentioned. Without IoT, when critical care was being provided to the patients, all equipments are connected in the ICU. There was no control or there was no visibility outside the ICU. So doctor has to come always in the ICU and see what is the now today the status or what is the health status of the patient. So this was limited. Now with the help of IoT kind of facilities, now you can monitor the health of patient. Even doctor can monitor on his mobile phone, or nurses and those supporting staff can monitor the health of the patient sitting in their rooms. So this is a facility which is being available. This picture shows about the IoT in hospital. You can see that everything is connected, and you can monitor through your phone. And the IoT application, a wearable application also I have shown in this slide, is a very interesting slide, and you can see that how glucose level is being monitored on your phone. And this is a slide where we connect our digital watch, like my digital watch is connected to my phone. So even I go outside India, the time on the watch will change accordingly. Okay, and watch senses that temperature, watch senses the humidity, and I can see how many steps I walk. Watch capture, and that is being transmitted through my phone to the cloud. And then every month I get a data, a consolidated data, that how many steps I have, how much energy I have spent, what is the health, what was my BP, average BP throughout the month, like that kind of information I get through this network. Let me end this today's lecture with a case study. So case study, this was published by NESCOM. TVS Motor is one of the largest company in the two-wheeler manufacturing in India, and they were having, in their plant, the assembly line was not connected, everything was being manual, So suppose assembly has been, some part is being added, or some chassis has been, now manufactured, and now somebody wants to, technician wants to know the availability of that chassis in the plant. No, they have no action except they have to change, they have to log into the computer and see that whether that part is available in the plant or not. They want everything should be connected, but those are not computers, they were no devices, So the assembly line machines were not connected, and data from the machines were not flowing from the data lake to the data lake. Means data lake is another which we will be studying. Data lake is another way of storing the data. Data lakes are little different from the conventional databases which we will be studying. So they were not having earlier this facility of connecting their machines, so that they will know that status of a different stage in the assembly line. And so what they have done, they have used a third party help, it's called Altigen, and they deploy their proprietary IoT platform. With the help of IoT platform, they were able to connect all the machines in their assembly line, and then they took the advantage of this technology. So this is what this company has done. In fact, in the same case study, they have mentioned that they got some 30% productivity enhancement of their workers in the plant. Real time insight into the parameters. So this is one of the very important case study which I will share the details about this case study in our handouts. This schematic diagram of this case study, that IoT link factory. It is you can see here there is IoT link factory. This will applicable to not only the TVS Motors, any factory, and then data being generated by different machines are being captured through on a data lake platform. We call it IoT platform, which we will be studying in the next lecture. IoT platform. Then with the help of a workflow that which data, because there are multiple machines in the assembly line, so workflow has to be applied. So through workflow we will take the data to the different levels, different authorization. Suppose a part has to be fixed, it requires some authorization, or it requires some approval. So this workflow will make that approval possible. So that is what. And then we have dashboard. There are not only one or two, there are a couple of dashboard which can be used in the factory environment to monitor what is happening in the plant, how many faults are coming, how many machines has been completed, how much work has been completed. So this is the analytics. Dashboards are being created. So like that, you will find that in this case, this kind of case study, and we will be studying all this kind of case study later on also. But you will find that how IoT is being deployed in company like TVS Motors for their manufacturing excellence, manufacturing efficiencies, and their workers' efficiencies. So with this, I like to finish this lecture. Hope that it will have given you some clarity, some understanding about the basic function of IoT. But the advanced aspects of IoT we will be discussing in the next lecture. So we have come to the end of this lecture, and I like to summarize the key takeaways of this lecture. We started with the core foundational technologies of 4.0, and then we discussed about the need of IoT, why IoT is required, and what kind of facility IoT is providing. Basically, we are able to connect any device on the network. Earlier, we were able to connect only computers and laptops. And then we have also studied the various options of connectivities and internet protocols, and we have seen one or two live world applications. So in this lecture, live world applications like in the hospitals, how IoT is being used, and IoT assured connectivity also we have seen, we have demonstrated with the help of that turbine, the turbine network, how the turbine network was actualized with the help of IoT ecosystem. So friends, this was some of the takeaways of this lecture. I hope it will be useful for you. Thank you very much.